So Colin, you want to tell us where we're going? That's cute.
We are going up to the San Ynez Mountains, right above UCSB, to look at some rocks.
Some rocks?
Particularly the Coldwater Sandstone Formation.
Exciting.
Yeah, it's really cool up there.
And we're hoping it's not gonna rain.
It'll be fine.
Alright. Wonderful. This is so pretty.
This is why I love coming up here.
Because it's so pretty?
Mm-hmm.
And having Gaga playing?
Basically.
So we're hiding behind a rock because it's hella cold.
Yeah.
And your girlfriend's a pansy. How do you feel about that?
Kind of limiting. In a way.
Well, at least tell me what we're looking at.
We're looking at the face of a big rock of sandstone. And I believe what you see here,
Where? The lines?
all these curved lines are old indications of river currents. So these would be called paleocurrent indicators. So you see these these waves within the sand particles.
Yeah.
And you can just see how water has eroded away. So this tells me that a river once flowed down this direction towards south, I believe. Pretty cool.
So, what about this one? The sculpted looking one?
Well, the reason why it's so skinny at the base is just because of the amount of wind and water erosion it's gone through.
But why not at the top?
Because you see where the rock is more tan and lighter?
In the center?
That's where the water was. That's where the river ran up. So that's been heavily eroded away, leaving that really bulbous rock up there exposed, kind of like a golf ball.
Yes. How long ago was there a river here?
I don't know.
Shouldn't you know these?
There are many rivers.
Okay. Let us continue.
Alright, so what you see here are beds of different rocks of sandstone, more like kind of a mud, finer grained sandstone. So originally, all these rocks got here is that all these rocks are called sedimentary rocks. They're all made up of tiny, tiny grains of sand, or just basically finer grains of other rocks. So what happens here is that all this is originally deposited in a bed of water. So judging by the sandstone, it's probably a river that this was deposited in, or what's called an alluvial fan, where a river empties out into a lake. So what happens is that these fine grains of sediment are deposited in the lake, and over millions of years, the addition of more sediment creates a ton of pressure, and let's say the rocks may be tectonically moved, so heat may be added to the equation, and they'll compress through a process of what's called lithification. So these rocks will compress at the bottom of this lake to become as hard as you see here, and then through some form of tectonic movement, like a fault or whatnot, they'll be uplifted out of the water. The water may drain out. I mean, this is over millions of years. There's always different seasonal changes. Water can just be dried out. So all these rocks have been thrust up, and that's why they're exposed as you see. That's how these guys are formed. So notice this is relatively pretty planar bedding. Sometimes you'll see, actually most times, you won't really see beds that are like this flat because they'll be dipping. So from what I can see, these beds are more or less moving in that direction. But they're still relatively horizontal. They're deposited like this originally.
Cool.
So here we are, standing on top of the San Ynez mountain range. on a nice outcrop of sandstone. And what's unique about the San Ynez Range is that unlike most mountain ranges in the US, it runs east-west. For example, the Sierra Nevadas run north-south, the Rockies do, so do the Appalachian Mountains. But this runs east-west. This is a relatively young mountain range because you know that part of California where it curves and then the ocean's to the south? Movement along the San Andreas Fault pushed this block outward, and then mountains formed here through thrust faulting, and so that's why you have an east-west trending mountain range like the San Ynez. Now, thrust fault is a type of fault.
Okay, what are these holes?
These holes, I don't know the specific term for them, but they are weathered parts of sandstone that have been carved out by water and rain over many, many years. And I'm not an expert on these, but all I know is that they were definitely formed through weathering processes like water and maybe like chemical deterioration of the minerals within the rock. And that's about it. They look pretty cool. They look like a caveman city.
Crater face. The gunshots are kind of scary. So these are the same holes that we were looking at, right?
Yeah. But it's almost like we're sitting in a really big one.
Apparently.
Just a little cave.
Look at the little lizards. Wait, where'd he go? And then he has a friend.
Who has no tail.
And his friend has no tail. What happened to your tail? Why don't you have a tail? Where'd he go? I lost him. Oh, there he is.
Okay, let's go.